Hello everyone, my name is Sandip and today we are going to continue our previous chapter. Which chapter we are talking about? That was friction, right? Okay, so first we have already completed the first chapter, that is force. Then we are now into our second chapter, which is called as friction, right? In the previous session we have already studied the types of friction, right? And yes, can anybody recall what are the different types of friction? Static friction, that's right. Then kinetic friction, good. Third one is rolling friction. Yes. Tell me which friction has the uh, list, or we can say which one of them is the place, right? That's right. It's a rolling friction. We have taken the example, right? If you want to go to the shop, nearby shop, right? It is easier to go by the skateboard instead of walking. Why? Because rolling is very easier than we can say our walking, right? So rolling friction is the less we can say. Then we also studied about the static friction, kinetic friction, right? So one more friction type, I can say it is the type of static friction, which is called as limiting force of friction. Anybody remember what is limiting force of friction? Yes, that's right. Limiting force of friction is the maximum static force of friction. We can say maximum value of static force of friction. So we have studied all those things. Now let's solve one question. Okay, try this question if you can solve this one. This is based on the our previous session. Okay, so consider this is the table and the block is kept here. Let's say of mass 2 kg. Okay, and I'm going to apply the force of 12 Newton here. Let's say mu s. Mu s means what? Coefficient of static friction. That's right. So mu s is 0.4. It does not have any unit, does not have any dimensions. We know that thing, right? Okay. So 12 Newton force is applied. Mu s is 0.4. Right. Now solve this question and tell me whether this block will have the kinetic force of friction or static force of friction. Okay. So I will give you 1 minute to solve this question. Let's see whether your concept is clear or not. Okay. Okay, so let's see, this is the 4 into 8, that is the maximum limiting force of friction. Limiting means static force of friction. What is the applied force? That is 12 Newton. So obviously this block will be in motion, and if the block is in motion, there is the kinetic force of friction which is going to act on this. Okay, so hopefully these concepts are clear with you right now. So let's see what we are going to study today. Topics to be covered. First one is the coefficient of kinetic friction, right? So we already have seen that it is called as mu k, right? And what is the mu k is less than mu s. I also know that. So if the mu s if we have considered this arbitrary value, it's need not be 0.4 every time, right? So mu k could be less than, it could be 0.2, 0.3, 0.35, but always can say that it is less than 0.4. Okay, so we already seen a lot of that. We will also solve some questions which are which will be up to, which will help you in the competitive exams in the future, right? Then second part we want to study is the friction a necessary evil. right? Necessary evil means obviously bad thing, right? So friction is evil, bad thing, but they are also saying it is necessary. Necessary means why we need the friction. We are also going to study that. What are the advantages? What are the disadvantages, etc. Then we are also going to talk about the fluid friction. Okay? So fluid frictions means, now let's take one example. Consider ship is moving in the ocean, right? Ship is moving in the ocean. So let's compare two equations, two cases, we can say two examples. Let's say on the road, bike is going like this. This is the bike. And in ocean, ship is going like this. Huge ship, we can say. And now, which will be easier to stop, whether it is bike or ship? Right? What we do if you want to stop the bike? We will simply apply the brakes, right? Very easy. What about the ship? And we just apply the brake and ship will stop there as it is, right? We can say the bike will stop at the exact point or just a little bit distance it will cover after you apply the brake. What about the ship? In ship, that is not the case. What happens in the case of ship? We have to apply actually inverse force. So consider if the ship is moving in this way, in this fashion, and obviously there will be engine is going to drive that ship in this way. Let's say let's call this as east. Okay. Now if you want to stop this ship, what you have to do actually, you have to start that engine or revert that engine into the opposite direction. So here we didn't apply the force or apply the engine's force towards the opposite direction. But in case of ship, what we have to do, we have to apply some opposite force or apply the force of that engine in the opposite direction, let's say west direction. So what we are actually doing, if that ship has some particular velocity, we are going to apply the force in the opposite direction, then it is going to stop, right? So why this is the difference. Bike we can easily stop, but ship it is very difficult to stop. Simple. I can say that the friction provided by this road is much higher, but friction provided by this ocean or water, we can say, is very less compared to your road, right? Therefore, even though if you apply some brake, obviously it is not going to stop. What we have to do, we have to apply the opposite force in the west direction, in the opposite direction, then only we can say that ship will stop there. Okay, like this. So this is the difference between the fluid friction and the solid friction. What we see, we have seen that the friction in the solids or fluids, we can say, not solids, friction in the fluids are really very less than solids. Okay, so obviously it is going to be difficult to apply brake. Now we will study in detail about the fluid friction also. Now let's solve some examples on this kinetic friction. So yesterday we already seen this graph, right? If you do remember, this is the frictional applied force, right? I have told you, if you apply the 20 Newton force, frictional force will also be 20 Newton. If you apply the 50 Newton force, or let's say 40 Newton force, friction also becomes 40 Newton. If you applied the 50 Newton force, now in this case, 50 Newton is the maximum value, threshold of the motion they are saying, or we can say this is the limiting force of friction. Limiting force of friction. We have studied this graph yesterday, right? Okay, they have saying the mu s is equal to 0.5. So after calculations, we actually draw on the same graphs, but values are different, obviously, right? So this is limiting force of friction. After that, what is going to happen? The body will just start to slide, right? Okay. What happens if you increase the force? Now friction force is not going to remain at 50, not going to increase, but it will, we can say, become less. This is 0.4, I can say, right? So you can see even they have said that US is 0.5, mu K we can consider as 0.4, right? So then this frictional force, that is kinetic force of friction, is going to remain constant. Here we can see static force of friction was increasing. It reaches at the maximum value and the kinetic force of friction started decreasing again. Okay. Now let's do one thing. You're going to solve some questions from competitive exams. So consider this is the inclined plane. I will draw one inclined plane here like this. And now the block is kept on this plane. Okay, let's say mass is 5 kg. Okay. Now, first of all, let's find out how many forces are acting on this block. Right. I know very clearly that mg is the force which is acting downward, right? Let's say this is theta, or let's say theta is equal to 30 degree. So this is the inclined plane which is making an angle of 30 degree with the horizontal. So first force on that block is acting downward, that is mg. Yes. Can anybody guess which one is the second force there? Normal force, right? So remember, can I show the normal force like this? No, right? Remember, normal force, we have talked about this normal force in the first chapter, that is our fourth chapter, right? Remember, normal force always acts perpendicular to the surface. So now this inclined is our surface in this case. So what I can say, normal force is going to act like this. Simple. It should make 90-degree angle with the surface, not the horizontal, but with the surface. So I got another normal force here. Okay. So I got mg as well as normal force. Right. Is there a frictional force here? Tell me, is there a frictional force in this diagram? Okay. How we can decide that? Yesterday I told you, if you keep the object on the horizontal table like this, right, and there is no friction, no applied force, right? So if this applied force is not there, so frictional force is also zero. Even in the graph, this graph can also say the same thing. If the applied force is zero, frictional force is also zero. Now let's talk about this graph. Now I cannot see any forces in this graph, but still there is a force which is acting on that block. And anybody guess what should be the force there? Right? So just take simple example. Let me see. I'll show this one. Consider this is the yeah. Consider this is the book or inclined plane, horizontal plane, right? Just like a table. And now I'm going to keep one plane here, one object. Right? Let me see if I have another object. Yes. Consider this is the block I'm keeping on this inclined plane. What is going to happen? It is there is no friction on this, right? But now what will happen if I move this uh, move this plane or rotate this plane in, let's say, angle theta? You can observe, right, this block which is kept on the inclined plane, at some point it is going to go down like this, right? It is moving towards the downward, or we can say it is moving downward. Okay, so why it is moving downward? Obviously there must be some force acting on that block, right? So how we can show that block? What is the force acting on that? So for that purpose, we will need the concept of the resolution of vectors, right? We have studied this method also, how to resolve the force into two components. You know this thing, right? So now consider we want to resolve this. Either you can resolve the mg or en, but remember, always remember that we should resolve the forces along the motion of the object, right? So obviously we know that 5 kg block, either it will move upward or it will move downward, right? So instead of resolving this normal force, what we are going to do, we are going to resolve this mg along this. Let's see how to resolve this. Okay, so what I'm going to do, let's resolve this component mg force like this. Okay? It will be perpendicular to the surface, and other component of this mg will be downward like this. Okay, so if you do remember something like this, so I told if this is the force F, this is the theta, then the component which is closer to the theta is called as F cos theta, and the other component is called as F sin theta, right? Similarly, so first of all, there are two angles I can say. Let's say this is first and this is second. Right? So tell me, using your geometry knowledge, tell me whether first one is 30 degree or second is 30 degree. Right? That's right. So we can say this angle is 30 degree. Okay. So if this angle is 30 degree, then what we can see, the angle or component which is closer to the angle is mg cos 30, and this other one is mg sin 30, right? Okay, so I got the two components. Now here you can see one thing, that n and mg cos 30 are exactly equal and opposite, right? So can I say n is equal to mg cos theta? Yes, normally for the horizontal table, we do say that n is equal to mg, right? But now what is happening for this inclined plane? This n is changing. N becomes mg cos theta, or we also know the value of theta, that is 30. Okay. Who is equating this mg sin theta? No one. So can I say mg sin theta is responsible for taking that block downward, we can say. Simple. Okay. Now consider if there is a motion. So can I say this is external force? Not external, this is internal force. We can say we are not applying any other force here, but now this mg sin theta is the force which is responsible for taking that block downward. Right? So if the motion of the block is downward, there will be a frictional force which is equal to Fr, right? Which is obviously equal to mg sin theta. When if this block is in equilibrium. Equilibrium means what? If this block is not moving, we have seen that when we kept that inclined plane, horizontal block was not moving. When I started making it some angle theta, what was happening? Still there was some time that block was not moving at all. Right? After giving it initial sufficient slope, I can say, then the block started to move. Similarly, here also happens same thing. It's not necessary that it will start moving directly. Right? It depends on angle theta or whatever is the mg sin theta. So when it will move when mg sin theta will be greater than your fr. Simple. Now let's do one thing. Let's calculate the value of mg sin theta. We also got the mass, we also got the g, and we know the value of sin 30, right? So first of all, let me find out the mg sin theta. So mg sin theta is equal to how much? 5 into 10, right? G approximately we are going to consider 10. We know that value is 9.8, but consider approximately it is 10. So sin 30. So can I say this is 25 Newton? Yes. So if this frictional force is less than 25, then obviously that block is going to move downward. If the frictional force is greater than 25, then obviously that block will be in equilibrium. Now, how to calculate the frictional force? Let's try this one too. You know the basic formula. What is the basic formula for frictional force? It is mu into n. Simple. Now let's take two values, that is mu s. Okay, let's take the same value 0.4, and let's say mu k is 0.3. Now normally we say n is equal to mg, right? In normal cases we know that n is equal to mg, but in this inclined plane we already written here n is equal to mg cos 30. So can I say this, instead of this n I can write mg cos of 30. So first of all, let's find out the maximum frictional force there. So therefore I have to use mu s, right, instead of mu. So how much is it? Mu s is how much? 0.4. Mass is how much? 5. G approximately we are considering G as 10. Cos 30, do anybody knows the value of cos 30? That is root 3 by 2, right? So let's try to solve this question. So this will be, I guess it will become 10 into root 3. And if remember, the value for root 3 is equal to 1.73. So you can substitute this value here. I will get 10 into 1.73. Can I say this is 17.3 Newton? So what is the maximum value? That is 17.3 Newton. Okay, simple. So now tell me, you got the mg sin theta's value, you got the maximum frictional forces value. How much is the, whether that block will move downward or not? Obviously, you can see the 20, it is 25 Newton is greater than 17.3 Newton. So it will not be in equilibrium. It will move, obviously. We know this one. Okay. So let's learn one more concept here. Now we already know that this block is going to move, right? What is the net force? Can I say net force is mg sin theta? Mg sin theta is taking that block downward. Who is opposing it? Fr, frictional force. How much is the frictional force? Is it 17.3? No, it is the maximum value of frictional force. What is the meaning of 17.3.3? If you apply the force 10 Newton, frictional force will be 10 Newton. If you apply the 15 Newton, it will be 15 Newton. If you apply 17.3, again it will be 17.3. But what happens if you apply the force 18 Newton, right? Is it going to be 17.3? No, right? It is going to reduce because this is the static force of, even limiting, we know it is the type of static force of friction. So what we can say in this case, mu s is 0.4, mu k is 0.3. So instead of FL, I have to calculate mu FK, right? Because now it started moving, 25 is greater than 17.3. So let's calculate this one. Mu n is how much? So this is mu k mg cos of 30, right? So mu k is how much? 0.3. M is 5. 10 cos 30. I know the value, that is root 3 by 2. So, okay, just a minute. 420. Yeah. Then can I say this will become 3 into 15. 15 divided by 2 is 7.5 into this value is 1.73. Okay, so we also have to calculate this value. So let's see how to calculate this. 7.5 now, 0.75. I can say this is 0.75 into 17.3 or 3 by 4 into 17.3. Then I just use the little trick to solve this type of question. Remember, if I can write this 0.73 means what? I'm shifting 1 point to the left hand side. So for this 1.7, it will become 17.3, right? The value is going to remain same. And 0.75 is nothing but what? 3 by 4. Let's try to solve this one. So this is 3. This will be 9. 17 3s are 51 divided by 4. Can I say this is 1, then 2, this, oh, this is how much? 1, 11, can approximately say it is 13, right? Approximately, let's take approximate value, 13 Newton, right? So instead of 17.3 Newton, our friction's value got 13 Newton. So now when we are calculating the F net, first of all, let's substitute this value, that is 25 Newton. Minus frictional force is how much? 13 Newton. Substitute that one. So what is the answer I'm going to get? 12 Newton. So the meaning is that the net force on this block is going to be 12 Newton, or with that much of force, that block is going to come down. Okay. Now, obviously, the block is in motion. I know that part. So let's do one thing. Consider when the block is moving, remember we show it by this acceleration A. Right, I will repeat. This is the acceleration A in our free body diagram. We are going to show that this acceleration means block is moving downward with some acceleration A. If I got the force, can we calculate the acceleration? This is a net force which is actually responsible for that block to go downward. Simple. Okay. So if I want to calculate the acceleration, I know the formula for force. Force is what? Mass into acceleration. So can I say acceleration is 12 divided by mass? What is the value of mass? 5, right? So this acceleration will be 2.4 meter per second square, right? So what I can see here, that block is not going to be at rest, but it is going to move with some acceleration. Acceleration is given by 2.4 meter per second square. Okay. So this is a question which will be useful for your competitive exams, obviously, like JEE, NEET, obviously in after 11, 12, right? So these are the important concepts we can see. Now, remember, we got the object's acceleration. Then now remember there are two types. Sometimes in problems they will say that the object is on the inclined plane or smooth inclined plane, right? Or they will say rough inclined plane. So there are two types. Smooth means, remember, when they say smooth, at that time frictional force will be zero, right? When they say it is rough, frictional force will be something. They will provide you some mus or mu k or anything, right? Consider 0.4. It could be 0.5, 0.6, like that. Okay. So these are the two types of the problems they will ask, right? And you have to find out using whether it is smooth or rough. What will happen if it is smooth? Consider this same diagram. We will consider every same situation, but only smooth part, right? So if this is the block of 5 kg, let's find out how many forces are acting that. One is mg. We resolve this, right? So if this is 30°, this becomes mg cos 30. This becomes mg sin 30. And this is our normal. Now, when we are going to say smooth surface, smooth means there will be no frictional force. So no one is going to oppose this mg sin 30. So can I say F net is equal to how much? F net is only mg sin 30. And we got the value of mg sin 30. We are using the same quantities, right? So mg sin 30 was how much? 25 Newton. So if the surface is smooth, force, that is F net, will be greater. Obviously, it was 12 Newton earlier. It is now 25 Newton. Now let's use our formula for MA. So acceleration will be 25 upon mass, or I can say 25 upon 5. How much is it? 5, right? 5 meter per second square. So you can see even the acceleration becomes higher. Acceleration becomes higher means obviously speed is higher. So what the friction is doing here? Friction is reducing the speed. So is it good or bad? Friction is bad, right? Okay, we can say friction is bad. But we also said that friction is necessary also. It is evil, but it is necessary. Why it is necessary? We will also see that one, right? So this is the smooth case, we can say, and this is the rough case. If they mention in the problem that the surface, inclined surface is rough, obviously they will mention the mu s, mu k, etc., etc. Right? Now let's consider. Let's try to solve one more question. If this is the inclined plane, angle is again 30°. Now the half part of this plane is smooth. So this part is smooth. And half part is rough. So I can say this part is rough. Normally rough part is shown like this by this. Okay. Similarly here also for this rough part also you can show it like this. Now consider this block starts from the upper end. This block starts from the upper end. And now it is moving downward. What will happen? We have to find that. Consider here initial velocity. It has velocity. Initial velocity is represented by 0. Remember, sorry, u. U is equal to 0. So what they are saying, that block is moving on this inclined plane, right? Now let's make two parts of this problem. First one will be for smooth part. When the block will reach here, it will have some velocity. I don't know what will be the velocity. This is the second part. When the block is going to move from this point to, let's say, at the bottom point, right? they are saying the velocity is 0. In the problem, they are going to say again final velocity. Final velocity means it is represented by v. Okay, so and consider this whole length is given as s. So can I say this small part is s by 2, and also second part is also s by 2. Simple. Okay, so let's try to find out what is happening in this case, right? We will also calculate what will be the time required for this block to reach at the bottom. Again, the same values we are going to consider. 5 kg block is there. Then again, can I say this smooth part doesn't have any mu k also, right? Mu k means coefficient of static friction, kinetic friction. Here it will have some mu value. Consider mu value is given as let's say 0.3. Okay. Obviously, we know we have to use the mu k instead. So in the problem, they will not mention whether it is mu k or mu s. They will directly provide you the value of coefficient of friction. Okay. Now there are three kinematic equations. V is equal to u plus at. S is equal to ut plus half at square. And v square is equal to u square plus 2s. So I will just tell you what are these things. U is the initial velocity. U is initial velocity. Then I can say v is the final velocity. Final velocity. T is obviously time. A is our acceleration. We know how to calculate the acceleration, right? We calculated this acceleration when there was friction, smooth surface or rough surface, and yes, it's called as displacement, or let's say distance in this case, right? How much distance it has traveled, right? Now, as I said, we are going to make the two parts of this problem. One part is for smooth, second part is for rough. Now let's talk about the first part. First part means only up to this much. How much is the length of this part? Is by 2. Okay, so if this is the diagram, we are only talking about the upper half, that is yes by 2. Okay, forget about this rough part. Now the block is here with the initial velocity is equal to 0. These equations are called as kinematic equations, right? Kinematic equations. And now we want to solve this problem. Okay, so initial velocity is 0. Motion is, we are considering this motion from where to where? From this point to, let's say this point. Let's give name to these points. So consider this is A point, this is B point, and this is C point. Okay, so we are talking about from B to C point only. This is our A point. Okay, this angle is given as 30 degree. Okay, so what we have to draw, first of all, FBD is important, right? So for FBD, mg is acting like this, then n is acting like this. Obviously, we can resolve these two components. Mg, this will be mg cos 30, and this will be mg sin 30. Is there a friction force in this case? No, there is no friction force. Why? Because we already said this is the smooth part, right? For smooth part, frictional force will be 0. Okay, so yes, chalo. So tell me, what will be the F net? F net means force acting on that block. En and mg cos theta are cancelling each other. So only mg sin theta is going to act there, right? And as we are using the same values, 5 kg block is there. So we already got this mg sin theta value. How much it was? That was 25 Newton, right? Okay. So this is 25 Newton. We also calculated the acceleration. Acceleration is how much? This is EMA, and acceleration is 25 upon mass. I can say mass was 25. Sorry, mass is 5 kg. So this will be 5 meter per second squared. Okay. So this is the acceleration with which that block is going downward. Okay. So what is the distance covered? S by 2 is the distance. What is the initial velocity? 0. We want to calculate the final velocity. Let's say this is the final velocity v dash at this particular point. Okay. Now we have the acceleration. We have the u is equal to 0. Now we want to calculate the, let's say, v. Okay. So how to calculate that one? We can use the third kinematic equation, right? So let's say this is v square equal to u square plus 2as. Let's use this one. We want to calculate v dash. V is final velocity is v dash, right? U is how much? 0 plus 2 into what is the value of acceleration? That is 5. Distance covered is how much? Yes by 2. Let me write this as yes by 2 only. Now here 2 and 2 will get cancelled, and we will have v dash square is equal to 5s. Just keep it as it is, right? We don't have to calculate the square root of that. We will write v dash square is equal to 5 into s. Remember, s is also our distance. Okay. Now let's talk about the second part. Second part is rough, right? So what I'm going to do, consider this diagram now. This is the part we are going to consider. This is the, sorry, it's not looking 30 degrees. Yeah, this is starting now. Okay, now block has already reached here. What is the initial velocity at this point now? Now here we were talking about B to C part. Now, sorry, C to B we can say, right? Here we are going to talk about B to A. B to A means what? This is A point, this is B point, this is C point. Okay, here what was the initial velocity? If V dash, right? So V dash is, I know the V dash. Then let's talk about the acceleration. As this is the rough patch, we can first of all draw the FBD, free body diagram. The mg is acting downward. This is 30 degree. Can I say this is mg sine 30? Right? We already have seen this one. mg cos 30 is here. Normal is there, and one more force is going to be here. That is frictional force. Right? So let's find out the F net first. F net is how much? mg sin theta is taking block downward. Who is opposing that? Frictional force. mg sin theta, we know the value, that is 25. We also got the frictional forces value in the first question. Now we are using all the same situation, same values there. So we can get the FR. FR was 13 Newton. We also got the value 17.3. Why we are not considering 17.3? It was the static or limiting force of friction. Now as the block is moving, we have to use the kinetic force of friction, that is 13 Newton. Let's substitute the value here. Yes. 25 minus 13, that is 12, right? Well, I can say this is ma, or acceleration is equal to 12 upon 5 or 2.4 meter per second square. Okay. So now for this, can I say initial velocity is v dash? That's right. What is the final velocity? They have mentioned that block comes to rest here. So final velocity will be 0. Okay. Then what is the distance? This distance is also yes by 2. So let's try to use the similar formula, that is v square is equal to u square plus 2as. Let's see what happens. How much is the v? V is 0. U square is how much? U means what? V dash, right? In this case, v dash plus 2 into, this is 2.4, or yes is how much? Yes is by 2. Simple. Okay. V dash, we already got the value of v dash, that is 5 years. Can I substitute it here? 5 years, right? 5 years, this will cancel 2.4 into yes. Okay. So we will get something like this equation. It is changing minus. Yes, acceleration was 2.4. Okay. No, don't have to use this equation. Just consider here, we will change this little bit here. Consider mu, they haven't mentioned the mu. We want to calculate the value of mu. We have considered the 13 as the frictional force, but now let's see, here it is going to change because this equation will not tally, obviously. So what I will do, let's find out the FK. FK, or frictional force, I can say, FR, and we want to calculate the mu. Mu is not given in this case. They are asking us to calculate the mu, right? Okay. So can I say FR is how much? Mu n, or mu, What is value of En? Is it mg? No, mg cos 30, right? mg cos 30. Mu we want to calculate. This is 5 into 10 into root 3 by 2. So can I say this is 25 root 3 into mu? Right? Now let's substitute this value instead of frictional force here. Where here we can substitute. Now 13 is not our frictional force. Instead of that, we are getting 25 by root 3 into mu. Right? So this will be our force. Can I say acceleration is how much? This is our EMA. So acceleration is not 2.4 in this case. Can I say 25 root 3 into mu divided by 5. 5 is what? 5 is mass, right? So this will become 5 minus 5 root 3 into mu. Let's substitute this acceleration here. So this is 5 minus 5 root 3 mu into s. Okay. Now we can get some value here. Now what is going to happen? This is s by 2 actually. So 2 and 2 is going to get cancelled. I know this v dash square. Let's take into the RHS side. It will become minus, right? So 5 minus 5 root 3 into s. Now what we can do, substitute the value of v dash square. What is the v dash square? That is 5s. Substitute here 5s. 5 minus 5 root 3 into s. Cancel out this s now, right? S will get cancelled. Then we will have only this one, this much of part. This is mu here, right? This is mu into s. Yes, this mu is outside. So once we got the s cancel out, only mu is remaining now. Can I write mu is equal to minus 5 upon 5 minus 5 root 3. This will be the value of mu. Okay, even I can cancel out the 5. I can even write this minus sign. Let's take it to the denominator. It will become 5 root 3 minus 5. Or I can take the 5 outside. That will become root 3 minus 1. Or only final answer will be, let's say, root 3 minus 1. Right, I can substitute this value also. So this will become 1.73 minus 1 or 1 upon 0.73. So this is the final value for mu. Okay. Once we got the mu, we can also calculate the time required for that block to move, etc., etc. So this is the question they could ask in the competitive exams like this. So now we have already solved the simple questions on the frictions. We solved some difficult questions on this kinetic friction, static friction, which will be useful for your competitive examinations, right? So this is all about the friction we can talk about, right? Now let's move to the theory part. Theory part, as we know, friction, second part. Friction is a necessary evil. Now let's see what is the meaning of that. Now we know friction is a bad thing. In this question also we saw that the force, that is a net force, is going to be less, right? If the friction is there, so we can say it is evil, it is a bad thing. But we are also saying it is necessary evil. Necessary means we need that friction. If the friction is not there, what will happen? Simply try to imagine. We can say, consider if your floor, if floor is not, or we can say if the floor is very smooth, what happens when we walk on the smooth floor? If we can say if the water is there, right? Water is on the floor, what will happen? You will slip, right? So friction is obviously needs to be there. Even consider one example, consider in rainy season. What happens in rainy seasons, right? There is water all over the road, right? So in the rainy seasons, there are a lot of chances, lot of cases of slipping of bike. Why the bike slips on the wet road? Obviously friction is less, right? So even though friction is a evil, but we need that friction, because if the friction is gone, bike will start sleeping. Even if you walk on the very smooth floor, we are going to sleep, right? You can consider that skating on the ice, right? You must have seen that in some movies. Skating on the ice, you can skate on the ice, but try walking on that ice. Is it easy? Obviously not. because the friction is very less there, right? Therefore, you can say friction is a necessary evil. So, what is the use of friction, or what are the advantages of friction? Here we can see, because of the friction between feet and the ground, we can actually walk. If there was no friction, obviously we do sleep. We know that thing, right? So, what happens in this case, in case of walking, when we are walking, right? We are actually pushing the ground behind, right? And the friction offered by the ground and the sole of the shoes, we can say that frictional force is going to push us forward. Okay, that's why we can say that friction is necessary for walking. Even you can take the second example here. We are writing on the paper, right? Anything we are writing in the notebook. Right? For that also there is a friction between your pen and that notebook, we can say, or paper. It makes it possible to write. Okay. Then similarly, vehicles, bikes, we already have discussed that if there is a rainy season, what happens? Road is wet, then there are a lot of possibilities that bike will slip. Right. Also, if you consider the road, normal roads, they are not exactly smooth, right? They are rough. They are rough, you can say. Okay, so these are the different things. Also, now let's see what are the advantages. We say that walking is one of the advantages. So you can write this down. Walking, then riding or riding bike, or we can say driving car. It is possible because of friction, we can say, right? Then we can also say writing. Then consider matchbox, right? When you want to leave the, we can say, that matchbox, you want to use that matchbox, right? There is a friction between the outer surface. You can observe that matchbox, right? There is a rough patch. There only we can use that matches to light the matches stick, we can say, right? So there is a friction between them. Then only we can actually use that matchbox. Okay. Now these are the applications or advantages of friction, right? Now consider, as we know now that it is needed, friction is needed, it is necessary, right? Now consider if you want to increase the friction. It's now, as we discussed, there is a rain in the rainy season. What happens? The road becomes very smooth, and then there is a possibility of slippage, right? So what we have to do, we have to increase friction. So let's see what are the methods to increase friction. Okay. So first method is make the surfaces rough. Make the surfaces rough. Means, as we have seen in the matchbox, the surfaces are rough there, right? They are deliberately making that surfaces rough. Therefore, with the friction, we are going to get some heat generated there, and that matchstick will get lit, right? Then about the tires do have the grooves, we can say. Tires are not totally plain, right? So when we say tire of bike or tire of car, this is not exactly like this, right? This is like this. So you can say there is some groove like this in the tires, right? So these are grooves, we can say. Grooves means you can see on the tires, right? There are some linings on that tire, right? Why? Because with that grooves, we can increase the rough surface. The tire becomes rough, so obviously. If you remember, if you have seen that, consider after a very long period of time, we have to change the tires of the car or bike. Why we have to do that? Because those tire becomes very smooth. If those become smooth, then bike will start slipping. Therefore, we do change the tires. Why they become smooth? Because of the friction, obviously. And we know the friction is also it is necessary, but it is a bad thing, right? Okay. Then consider the third method, You can say there are spikes on the running shoes of athletes, right? If you have seen in the race, right, 100-meter race, 200-meter race, in that race, what happens? Those shoes of the athletes, shoes are provided by which companies, right? Adidas, Nike, big brands are there, right? If you observe those shoes, the sole of the shoes, there are spikes on that. Spikes means what? We can say it is something like nail, but not exactly nail, but very small spikes, we can say, which is going to provide some friction there. Then consider machine belts. Machine belts are made from special material. Right? So this machine belt means what? Where are there are many machines which requires pulleys, something like that. Right? You must have seen this type of machine in that floor grinding shop, right? They have that belt is moving on this two pulleys, right? And these belts are not should not be smooth. If those are smooth, they will slip on these pulleys, right? So these are made of special material to provide some extra friction to that, right? So these are the types we can say to increase the friction. Even you can consider the in our garden, normally what we do, we just make the surface like rough. How to make that surface rough? Just place some stones on that garden, right? So we will not slip, right? So those stones or rough stones, we can say, those are made for the um, increase the friction. Even the bathroom floor, you can consider, even on our normal floor of our house, obviously it is normally we use the spartex flooring, etc., etc. Those are smooth flooring, but for the bathroom, if you observe, the floor is rough, right? It is rough compared to our normal floor. Okay, so these are the types to increase the friction, we can say. Okay, now now let's talk about the disadvantages. Now this one, advantages means it is the necessary part. Friction is necessary for us. Disadvantages means it is the evil part. It is the bad part. Okay. So you can see some examples here that if you want to drive the cycle, obviously there are two types of frictions. Normally we know that a friction between the tire and the road. There is another friction which is air resistance, right? Which is fluid friction, obviously. Right? So air resistance is also there, which is going to make it difficult for cyclists to ride that bicycle, we can say. Then wear and tear of materials, right? Wear and tear means obviously we have seen that after some years you have to change the tires of your car or bike. Right? Similarly, you also change your shoes or slippers. Why? Because the sole of that shoes is also going to become very smooth. Once it becomes smooth, you are going to sleep. Simple. Then it causes the noise pollution. Right now, this aeroplane, we can see aeroplane is moving. That aeroplane is moving means obviously there is no relation between the road and the aeroplane. But what we can say, there is a air resistance. So air is actually applying some friction, and because of that, there is a lot of noise. Right? If somebody lives nearer to the airport, they are going to observe that there is a lot of noise when the plane takes off or lands. Right? Then in the forest, there are friction. Now we can say, where is there friction? Now we can say those trees are also, we can say they are getting rubbed with each other, right? So what happens? Because of that friction, heat gets created. If you must have heard some time back, there was mm, there was fire in Australia, right? Australia, there was very big fire in Australia because of this friction, right, in the forest. Okay, so like that. So those are the disadvantages of the friction, we can say. Let's list out more disadvantages. So first is it reduces efficiency of machine. Efficiency of machine. So if you go to the any manufacturing plant, there are a lot of machines, and in machines obviously there is a friction. So if there is a friction, it will reduce its efficiency. Efficiency means what? How much output we can get from the machine, right? Then how the efficiency is reduced? Because this friction produces heat, right? So some energy is converted into heat which we do not require, and this heat also can damage that machine. This heat damages machine, we can say. So this is the disadvantage of friction. Then wears out the friction, wears out the machine. Means similar to our tire, or we can say sole of the shoes, right? Wears out the sole of the shoes or tires, right? Or tires, you can say, right? So these are the different disadvantages. Now, obviously, if the friction is a lot more, disadvantages will be very high. So also we need that friction. So what we can say, we need the sufficient amount of friction. It should not be very high. It should not be very low, right? So sometimes we have to uh, decrease that, reduce that friction, we can say. So methods to reduce friction. So what we can do to reduce friction? So first of all, we can polish the surface. Polishing. Polishing means if you would have considered for the when you are having some furniture work in your home, they have that sandpaper and they have polished that surface, wooden surface, right, to make it smooth. That is called as polishing. So smoothing of any surface is polishing, we can say. Then we can use the lubricants. Lubricants means what? We actually have discussed this in the previous lecture also. You can apply oil, grease, etc. all these parts on the machines or the surfaces which are in contact. Like for example, as so I also told you in the previous session that the door is cracking, door is making some cracking noises, then we can apply some grease or oil, etc. Then use the ball bearings. Use ball bearings. Ball bearings means what? Now consider if these two surfaces are moving on each other, right? Now obviously there will be sliding friction. Instead of that, what you can do, now these are the balls of the small balls, we can say small metal balls. So instead of sliding those two objects on each other, now they are rolling on these balls, right? So these balls obviously going to reduce some friction, right? Then what you can do is use the rollers. Use rollers and wheels. Rollers and wheels means obviously for your washing machine, they have some small wheels, right? So it is easier to move that washing machine, right? Okay. Now, fifth point is streamline shape. So these are particularly for the fluids, we can say. To avoid the fluid friction means, if you can consider the aeroplane, how the aeroplane looks like, something like this. It has some conical shape in front of the plane, we can say. So if this is the plane, right, something like this is the shape. Right? So plane, rockets, all those have the same shape. So this shape is responsible. This is called a streamline shape, and it is going to reduce the friction which is coming from the forward direction. Right? This is aeroplane is in air. We know that part, right? Even you can consider the rockets. Rockets also have the same shape, right? Then even you can see the living things in the water, like fishes. Fishes will also have the same, something like this. They also have the same shape, the narrower shape in front. Why? Because they have to work against the water, right? So this is called as streamline shape. Okay, this is mostly used in fluid part, we can say. Okay, now, so this is all about the why the friction is necessary even. Now let's talk something about the fluid friction. This is the last part of our session today. So fluid friction, as we can see here, streamline shape. This is the aeroplane. This is the better diagram than what I have drawn, right? So fluid friction means the air's friction here. So streamline shapes make it easier to move, reducing the friction, we can say. Even you can see the boat The front part of the boat is like this, right? Narrower part, right? So it is going to reduce some friction. So we already talked about the friction. Fluid friction means what? Which it is the friction in fluids. Fluids means, what are the fluids? It could be water or any liquid, we can say, or it could be air or any gas, right? Gas is also fluid. Remember, liquid as well as gas, both are fluid. Both are going to give you can say, opposite friction there, right? So obviously we have studied at the start of the lecture that this fluid friction is less than solid friction. Okay, so now consider one example from the tower, from the building. You throw one stone like this, and second is, let's say, feather like this. Which one will reach earlier on the ground? Obviously stone will reach earlier, right? This feather is going to take a lot of time. Why? Because of the air friction, we can say. So air friction is going to act upward in the upward direction. It will be more efficient on the feather instead, or rather than stone, we can say. Therefore, on feather, air resistance will be higher. Why? Because obviously its area is higher. Its mass, area of the feather is higher than the stone, we can say. But mass is very, very less, right? So as the mass is less, air resistance will have more effect on the feather than the stone. Okay. And how to reduce this fluid friction? We have already seen that streamline shape, right? So if you have the streamline shape, then you can easily reduce that friction. Okay, simple. So like this aeroplane, we can say, or the ships, etc. Okay, so this is about the uh, fluid friction. You can also take one more example, meteors, or we actually I told you this one also in the previous session. When the meteors comes towards the earth, meteor means what? Rocks, oddly shaped rock, they do come something like this. Now there is an atmosphere around the earth, right? And even though we know the air resistance is, air friction is very less, but the speed of this meteor is very, very high, right? So when they enter the atmosphere of earth, our earth's atmosphere is going to apply some resistance there, right, to this. And as the velocity is very high, it is going to create some heat, right? Therefore we can see some light when the meteors enters our earth's atmosphere. It also called, we can also call those as meteor showers. Okay, so this is the example for fluid mechanics, fluid friction, we can say. Okay, so that's the whole part in today's session. Let's try to solve some questions now. So block of mass 10 kg is kept on rest on a horizontal surface. Find a normal reaction and limiting friction that can come into play if the coefficient of friction is 0.2. Now we already solved a more difficult question than this, so I think you'll be able to solve this question very easily. 10 kg, what they are asking, normal and limiting friction. Limiting means what? Maximum static friction. So I think you can easily solve this one. Let's say first find out how many forces are there. That is mg, and the normal is acting upward. So can I say normal is equal to mg? Chalo, do the calculations and find out the normals. What is the normal force? Also limiting force of friction, we have the formula mu n. Mu n is equal to what? Mu mg, right? So substitute the values. Mass is how much? 10. G is how much? Normally we do take 9.8 for simplicity, but now consider 9.8. So this will becomes 98, right? Let's see whether we have the 98 as option. Yes, 98 is option there. Also, mu mg will be how much? Mu is given as 0.2. 0.2 into 98. How much it will be? I think it will be 19.6. So normal is 98 and the limiting force of friction is 19.6. So let's mark this option simple. Let's try to move to the next question. Arrange the following types of friction in decreasing order. So decreasing order means which one should be the highest force of friction? There are limiting Then limiting means static force of friction, right? Static one is highest. Then kinetic. Kinetic also have the second name sliding. That's what they have used here. And then we have the rolling. So which option is correct? Yes, static means maximum value is anyway limiting. So I can say C is our answer, right? Now, consider the next one. Which of the following do not reduce the friction? Now, we have seen the methods to reduce the friction. Ball bearings reduce the friction. Lubricants reduces the friction. Then rolling, obviously rolling is going to uh, reduce the friction. Grooving and threading. Threading and grooving is used in the tires part, right? We have talked about the grooving, right? So there are some lines on that tire, it is not smooth. So grooving is not actually reducing the friction, it is going to increase the friction. So this will be our option, right? And meteors, we talked about this one too. Meteors burns on entering the Earth's surface due to what? Obviously friction, right? So not atmospheric pressure, it is wrong. Solar radiation, it is not related to solar radiation. Excessive friction, we can say. So these are some questions. So this is the whole chapter of our friction. We have completed the every part of the friction. So it is easy chapter. So study on that and find out the examples. Try to solve the questions on that. Try to find out the different numericals. We also try to solve the questions on numericals which will appear in the competitive exams, right? Okay. And if you do have any questions, please put them into the forum. Okay. So yes, we have completed the friction. So today we'll stop here. Thank you very much. Have a nice day.